Okay, so on Friday, we blended it together for 1, 4, 2, 4, 3, which was rigid transformations, right? Like where they don't change shapes. And there was 3 different types: translations, rotations, and reflections, which all of that content will be covered on that quiz, which is going to cover, it's going to go 4, 1 to 4 to 5, 3. Actually, it's like 4, 1 to 4, 3, and then 5, 1 to 5, 3. So there'll be questions, some of them like these where you actually have to graph, and then some of them where you'll do it without graphing. So number 1, I'm going to talk about like 1, 2, and 3, like how you could do it both ways. Can you use it while graphing? Yes, but could you also do it without having to graph it? So it said to graph the quadrilateral with the vertices and then do all the translations, right? So this was our pre-image, which was A, B, C, D, okay? And then all of 1, 2, and 3 are translations, you're shifting. So you actually can do the shifting without actually graphing it. For each x, I would add 4, and to each y, I would subtract 2. So I would add 4, subtract 2, add 4, subtract 2, add 4, subtract 2. Because there are going to be questions on your quiz in which you don't have a graph provided. So that's when I would want to know how to do it this way. So then A prime would be 0 and -1. B prime would be 1 and 1. C prime would be 4 and -2, and D prime would be 2 and -2. This is -1. 4 and -1, yeah. And then if I was to use my graph, every x is going to get shifted to the right 4 and every y down 2. So I would take my C, which is here, go 1, 2, 3, 4 to the right and down 2, and that would be my C prime. Do the same thing with B, 1, 2, 3, 4, down 2. This would be B prime. With A, 1, 2, 3, 4, down 2. That would be A prime. And with D, 1, 2, 3, 4, down 2, and that would be D prime. So what should not have changed is the overall shape, because this is a rigid transformation. It should keep the same shape. It's just a slide, okay? So I won't graph each of the next one, but I'm going to do the same thing with the coordinate points. So this time it says to subtract 1 from the x and subtract 5 from the y. So I'm going to subtract 1 and 5 and 1 and 5 and 1 and 5. And A prime should be -5, -4. B prime, -4, -2. C prime, -1, -4. And D prime, -3, -5. And then the last one, it's your xy. Your x is getting added 3 and your y 6. So +3 + 6 + 3 + 6 + 3 + 6 + 3 + 6. And A prime is -1, 7. B prime, 0, 9. C prime, 3, 7. And D prime, 1, 6. So again, you'd want to be able to do that with and without the graph. All right, then the next one said to graph the polygon and then use the reflection provided over whatever the equation is. So for A, I would do -5, 6. B, -7, 8. C, -3, 11. And it wants you to reflect it over the x-axis. So I want to count the distance up and then reflect that point down. So it's going in the other direction. So I would get -5, -6. I would get -7, -8. And I would get -3, -11. So I'm going in the opposite direction over the x-axis. I'm going to do 6 since I'm zoomed in on this side. So 6, -1, 4, 2, 5, 5, 2, and 4, -1. And I'm reflecting over the x = 3 line. So x = 3 would be a vertical line. and I want to go in the opposite direction. So here I'm 1 away to the right, which means I'm going to go 1, I'm 1 to the left, which means I'm going to go 1 right. This is 1, 2, 3, 4 to the left, so I'm going to go 1, 2, 3, 4 to the right. This one is 1, 2 to the right, so I'm going 1, 2 to the left. And this is 1 to the right, I'm going 1 to the left. And then that would be reflected over the x equals 3. Five, negative 1, negative 2, 1, negative 1, negative 3. Oops, went the wrong way, sorry. Negative 3. And it's the y equals x line. Yes. So y equals x is through your origin. And you went this direction, which means I'm going the other direction about 1.5. Here you're 1 away, so I'm going the other direction. Here 1, 2, you're going 1, 2, other direction.
Okay, so a horizontal one would be what?
What do you mean a horizontal one?
When you reflect on horizontal.
On the horizontal is the x-axis, or y equals 0.
So would it be y equals x?
No, that's what I just did. Like that's 5, the diagonal.
Okay.
7, last reflection 2, negative 4, 6, negative 1, 9, negative 4, and 6, negative 6. And I'm reflecting over y equals negative 2. So y equals negative 2 is a horizontal line. All of these, I'm going to move vertically. So this is 1 unit up. I'm going to move 1 unit down. This is 2 units down. I'm going to move 2 units up. The bottom one is 1, 2, 3, 4 units down. So I'm going to go 1, 2, 3, 4 units up. And this is 2 units down. I'm going to do 2 units up. And there's your reflected, or your image, right? Pre-image was the first, image is the last. Okay, the last 3, it said to graph the polygon and its image after the rotation of the number of degrees about the origin. So you also want to know how to do this without a graph because it's 90 degrees. So remember 90 degrees, we switch the order and you change the sign on the initial y, which now becomes the x. So if I take this coordinate point, which is 1, 1, I'm going to switch them and change the sign on the first one after I switch. That would be my A prime. The B, which is 2, 4, I'm going to switch them and change the sign on my new x, so negative 4, 2. And the C, which is 4, 1, I switch them and I change the sign on the new x. So my image would be negative 1, 1, negative 4, 2, negative 1, 4. That would be a rotation 90 degrees. For 15, it's 270, and 270 we switch and we change the sign on the new y, which was the original x. So if this is negative 1, 1, 2, 3, 4, negative 2, 2, 1, negative 1, and 1, 2. Again, we're going to switch and change the sign after we switch on the second one. So D prime becomes 2, and then negative 2 would be there, so I make it positive 2. E prime, I switch, so I make it 4, and it was negative 1, so it will be positive 1. F prime, I switch, so it's 2, and I change the sign on the second one. And G prime, I switch, and I change the sign on the second one. And then 16, 180, I think is the easiest because you change the signs on both. So this would be 1, 2, 3, 4. This is negative 4, 1. So H prime becomes 4, negative 1. I is negative 2, 1, so I becomes positive 2, negative 1. J is negative 1, negative 2, so this becomes 1, 2. And K is negative 4, negative 4, so that becomes 4, 4. So again, for like as far as quiz questions goes from 4, 1 to 4, 3, you've got to be able to distinguish, is it a translation, which is that slide? Is it a reflection over a line? Is it a rotation from a picture? That should be easy because that usually has an arrow. And then how to write the rule for the translation. Like if I gave you those two images, could you write the rule? And also if I gave you the rule, could you get the new points? All right, so the good news is that 5-1 is all stuff I would say you should definitely know, okay? It's about angles of a triangle. So we're going to classify triangles. You have to learn that they add up to 180 and learn a couple of things about an exterior angle or if it's right triangles. So first of all, a definition of a triangle. It's a figure formed by 3 segments, so they have to be straight sides, joining 3 non-collinear points. So they have to be non-collinear. The point where the segments meet is called the vertex. So just a little bit of vocab there. Each of these would be vertices, and they are point. And the segments are sides. So when I name the sides, I can use 2 letters, or I can use 2 letters with the segment over them. And of course, every triangle has 3 angles, 1 at each vertex. There are 3 ways to classify a triangle by its sides. Scalene, which means there are no sides the same. Isosceles, which means there are at least, and at least is important there, at least 2 sides the same. And equilateral, which means all 3 sides are the same. So if you're given a diagram and it asks you to identify, like classify it by a side, and it is equilateral, even though it is also isosceles, equilateral is the better way to describe it. So if it has 3 sides, not only is it equilateral, but it's also isosceles because isosceles says at least 2 sides the same. But if you're choosing between those 2, the better descriptive word is equilateral. Okay, so 3 sides equilateral, 2 sides isosceles, no sides scalene. There are 4 ways to classify it by its angles. If they are all less than 90 degrees, it is acute. If one of the angles is greater than 90 degrees, and it can only be 1, then it's obtuse. If one of the angles, and again can only be 1, is right or equal to 90 degrees, then that triangle is a right triangle. And if they are all equal to each other, then it is equiangular. All right, so the triangle sum theorem says that the sum of the measures of the interior angles of a triangle is 180 degrees. Yes, it has a name, so if I'm going to use this in a proof, I can use the name, but you don't have to use the name. You could just say all the angles in a triangle add up to 180 degrees. And the exterior angle theorem also has a name, so you can use it by its name. Says the measure of an exterior angle of a triangle equals the sum of the measures of the 2 remote, which means non-adjacent interior angles. So in this diagram, angle 1, which is on the outside, that's your exterior angle, would equal to the sum of the 2 inside that's not next to it. So this would equal the sum of angle A and angle B. All right, so corollaries, which is something that's just easily determined from a theorem. So it's like if you know the theorem, this kind of leads to that next decision pretty easily, okay? That's what a corollary is. So that's the difference between a theorem, a corollary, postulate. And the corollary to the triangle sum theorem, which is what Cal had just asked about, it says, or no, sorry, not you, that's the right triangle one. This says the acute angles of a right triangle are complementary. So we know the triangle sum theorem says that they add up to 180, and it should be easy to figure out that if one of them is 90, that means the other 2 have to add up to 90, which makes them complementary. So corollaries are usually pretty, like, obvious, okay? But it does have a name, so you can use it. And it basically just says the sum of the two non-right angles in your right triangle have to add up to 90 degrees, which makes them complementary. Yeah.
Were any of the previous theorems corollary?
No.
That we've learned?
No. All right, so this one just says, state whether the triangle with the two angles having the given measure is acute, right, or obtuse. So for each of these, what do you need to do first? Add them and subtract from 180. And then based on what you get, you would determine if they're acute, right, or obtuse. Go ahead and work them out. All right, so if you look at A, if I add 55 and 43, I get 98 subtracted from 180. What's the missing angle? Nope, what's the missing angle?
82.
82, which makes this what? Acute. B, if I add 47 and 43, I get 90, which makes the missing angle 90, and this triangle is right. C, if I add these two together, I get 155, makes the missing angle what? 25, which makes this triangle acute. D, add them, I get 66, subtract that from 180, what's left? 114, which makes this obtuse, good. And the last one, add them together, I get 90, which means that last one is 90 again. And this is good. All right, now we've got some application of the third angles, the exterior angles, and also like vertical angles. All that stuff is going to come back in. So if you look at A, okay, it says to find the measure of angle A. But for example A, in the triangle on the left, I have two of the three angles. And on the right, I only have one. I'm trying to find this angle here. How do I find it? Kala.
Don't you find the measure of the angle that's on the other triangle?
Which would be what? Nope.
Alternate exterior angles.
Nope. This missing angle is 50 degrees. Why do you know it's 50?
Because you subtract 130
Good.
from 180.
So
and then
these
the other
three
side-
have to add up to 180. So I got that one.
and the
Then,
other side would be 52 because of the vertical angle.
good. And then A is?
And then A is 80 because 50 plus 50 is 100.
Good. So we just used,
You said no.
I was talking to her. She was walking me through the question, and we were directly talking about that angle. And I said no to alternate interior because there's nothing about
I said
parallel.
exterior.
Doesn't matter. It's alternate exterior.
Yep.
There's no parallel lines here, so you can't use any of that, right? So if I was justifying all those steps, because eventually we're going to work our way back there, right? I would have said that angle, the first one, angle 50, or that angle is 50 degrees, and that's the triangle sum theorem. Then linked it to the blue angle, that's vertical angles theorem. Then found the missing angle, that's triangle sum theorem again. So start to think, how would they ask me to justify these steps? Because we're going to get back there.
Some just don't understand my logic.
Okay. There would be no alternate exterior angles there, so I just want you to be careful because there's no parallel lines. All right, B, this is 40, this is 60, this is congruent to this, which means that missing angle has to be what? 60 degrees. So no matter, like if I add the two on the bottom right, I'd get 100 here. That makes this 50, that makes this 50, work backwards, and I would get that that's, wait, just kidding.
Wait, I
That's
thought
not
the
80.
sum of all
This
these
is
was-
80. This is 80. And then work backwards to get the angle A would be 60.
I'm confused. I have a question.
Yep.
Even I don't. I have Mars.
Go ahead, ask your question.
So I added 60 and 40s.
Yeah, and you got 100. Did you not get 100?
Yeah, I did.
Okay.
And then,
So then this top angle is 80, right?
oh, okay. You originally said it was 60.
And then I corrected it. Yeah. All right. C. On the right, you've got the 30, the 110. If I add those, I get 140. That means that top angle is what?
40.
40. And then this would be 40, which means the missing angle is 110. Easy stuff, right? This section should be on the super easy side.
It is.
Good.
But
Not this section, no. No. I mean, it gets a little bit more complicated, but not this stuff. All right, so find the measures of angle A. This time we're using our exterior angles theorem, or triangle exterior angle theorem, which says,
So that means that the two angles
Good. So this one plus this one equals 120, right? So how do I find angle A?
Subtract 120 by 80.
Good. So what's angle A? 40 degrees. And E says in triangle EFG, the measure of angle G is 100. The measure of FEH is 3 times angle F. So if this is an X, that one would be 3X. Find the measure of angle F. So I can say that 3X equals X plus 100. Subtract the X. 2X equals 100 and X equals 50. That's the measure of angle F. Okay, if it had asked for the measure of angle FEH, it would be 150. So just be careful and pay attention what it asks for. Easy stuff, right? So the only thing, like only even like variation of this kind of stuff would be like you might see something like this is 3X plus 10 and this is 2X and this is 7X minus 5, something like that, in which you have to set up an algebraic an equation to solve it, okay? That's really the only kind of variation on these kinds of questions that you'll see.